In this video, we will learn about polymorphism, virtual function and abstract class. So let's get started. Let us first understand what is polymorphism. Polymorphism refers to the ability of something to take on different forms or states. The term polymorphism originates from Greek roots where poly means many and morph means forms or shapes. Thus, polymorphism means many forms or shapes. For example, a person can be a firefighter, a doctor, or even a policeman. Similarly, we can have a variety of shapes. For example, a triangle, a circle, a rectangle, or even a polygon. In the same way, vehicles can take up many forms. For example, we can have a truck, a bus, or even a bike. Just as we have seen several real-life examples of polymorphism where one thing can take up many forms, in the same way object-oriented programming languages also support polymorphism where one name, typically a method or a function name, can be used for several related but slightly different purposes. The diagram in front of you represents a classification of polymorphism in object-oriented programming. We have two types of polymorphism, namely compile-time polymorphism, which is achieved through function overloading and operator overloading, and then there is runtime polymorphism, which is achieved through function overriding and virtual functions. Let us understand all of these terms in more detail. Compile-time polymorphism is the one where the compiler binds a function call to the appropriate function definition at compile time. It is also known as early binding or static polymorphism. It is achieved through function overloading and operator overloading. This means that compile-time polymorphism in C++ enables functions and operators to work with different types and parameter lists. Function overloading allows us to define multiple functions with the same name, but they are all different from each other in terms of their parameter list and sometimes even in terms of their return types. The decision of which function to call is made by the compiler at compile time based on the function signature. Let us understand function overloading through a small example. Let us suppose that we want to calculate area of a circle and area of a rectangle. And for that we are creating one function but two definitions. So let's do it. Area of a circle, and it will be calculated as area, but the return type is double. We will keep the radius as double as well. Okay, this is the parameter for the function, and this function definition has single parameter, and it will return pi r square or 3.14, which is the value of pi, multiplied by radius and once again multiplied by radius. So this is equal to pi r square. In the same way, we define another area function, and this time we are going to calculate area of a rectangle. Let us suppose that the return type is still double. Name of the function is also area, but this time we will have two parameters. One is length and another one is breadth. Even though the data types of all the parameters are the same, but their numbers vary, and that is why compiler will be able to differentiate between these two area functions. This function will return area as length multiplied by breadth. Now it's time to define the main function. Inside the main function, I am going to call both these area functions. So first of all, I will provide the value for radius. Let's say double r equal to 9.8. This is the value for radius. Similarly, I want to provide value for length. Let us say length is 20.3, and this is the value for length. Similarly, value for breadth is, let's suppose, 12.4, and here we mention that this is the value for breadth. Now inside the main function only, I am going to calculate area of the circle, and here I will be typing the name, and then I will provide one argument r. This r will be copied into this radius parameter, and the formula 3.14 multiplied by radius will be giving the value of area of the circle. Similarly, I am going to calculate area of the rectangle, and this will be equal to, I have to type here area and then L comma B and then semicolon. Now we have both functions with the same name, and the compiler will be binding this function call with the first function definition since it has only one parameter, and similarly it will bind this function call, the second one, to the second function definition since it has two parameters, and this is known as compile time polymorphism, since the compiler will be determining which function call to bind to which function definition at compile time. If we execute it, area of the circle and area of the rectangle both have been calculated and both the functions have run properly, but the overall idea was to show you how function overloading works. Operator overloading is another form of compile time polymorphism. It allows us to define or change the behavior of existing operators in C++ for user-defined types such as classes or structures. In order to overload an operator as a member function inside the class, we have to use the keyword operator followed by the operator symbol, and then we mention any parameter list, and we define this function just like any other member function. In C++, we can overload most of the operators, but there are a few exceptions. For example, we cannot overload a scope resolution operator, member selection operator, ternary conditional operator, size of operator, and member selection through pointer to member operator. In this program, I am going to show you how to overload Unary ++ operator. So first of all, we will define a class named student. Inside this class, under private access specifier, we are going to have one data member as roll number, which is of integer type. Then under public access specifier, we are going to construct one default constructor, and constructor name should be the same as that of the class. Inside this constructor, we are going to initialize roll number with value 0. So this is the default constructor. Next, we are going to define one member function called display, which will display the value of the roll number. So here we will type /n roll number is equal to, and then we will get the value for roll number. Lastly, we are going to overload Unary ++ operator when used as a prefix. So here we will have to type return type, which is void, followed by the keyword operator. Then we mention the operator symbol, which is ++ in this case, but this is a member function, so we must also put a set of parentheses. Then inside a pair of curly brackets, we are going to increment the roll number value. So we will type here ++ roll number. This will increment the value of roll number, and now next thing is to create the main function. So here I will define int main. Inside this function, I will create one object of class student s1, and let's say I create another object as s2. After this, s1 dot display function. So when I call this function, I will get the value of roll number. Similarly, I will call s2 dot display, and let's run this program. So here we will type return 0 and run it. So as you can see, roll number is 0 for both objects s1 and s2. But now I want to increment the value of roll number. So I am going to apply ++ operator to object s1 and similarly to object s2. And once again I am going to display their values. So I will just copy this code and paste it over here. Let's rerun the program. And now you can see, after applying Unary ++ operator to the object of the class student, we have got roll number value as 1 for both the objects. So this is how you can apply Unary ++ operator to an object of a class. And this is the typical example of operator overloading. The second type of polymorphism is runtime polymorphism, where the compiler binds a function call to the appropriate function definition at runtime. It is also known as late binding or dynamic polymorphism. It allows the program to determine which function to execute based on the actual object type at runtime, and it is achieved through function overriding and virtual function. Function overriding is quite similar to function overloading. The only difference is that in case of function overloading, multiple functions or methods with the same name belong to the same class. But in case of function overriding, multiple methods with the same name belong to different classes. So in case of function overriding, a subclass provides its own implementation of a method that is already defined in its superclass. This allows the subclass to extend the behavior of that method to meet its own specific requirements. For example, here we have a base class named person having its own member function called display. Then we have a derived class lawyer which inherits from this person class, and it redefines the display function, and this is known as function overriding. Virtual function plays an important role in object-oriented programming. It uses the concept of late binding. Basically, both the base class and the derived class have a function with the same name, but the function inside the base class is declared using keyword virtual. It is used to achieve runtime polymorphism. The compiler here determines which function to execute at runtime, the function that belongs to the base class or the function belonging to the derived class based on the contents of a pointer to base type. Let us see an example. In this program, I have created one base class named vehicle having its own member function called display, which has only one print statement that says this is a vehicle. Then I have defined a derived class called car which inherits from vehicle class using public derivation mode, and it overrides the display function of the base class, and inside this function I have written this is a car. Now that I have defined both the base class and the derived class, it's time to create a pointer to the base class. And the base class name is vehicle, and since the pointer is of base type, so we have to type base class name, then pointer operator, and then the name of the pointer, which is PTR. Next, I am going to access the display function of the base class using pointer. This symbol, which looks like an arrow, is the this operator. So we have written pointer name, this operator, and function name. Let us run this program. And the output here says this is a vehicle. In the next step, I am going to create an object of the car class. The class name is car, and let's say the object name is car1. Then I will assign the address of this object to the pointer to the base type. Since car is a derived class, therefore the pointer to base type is compatible with the derived class object. So here I can assign the address of the derived class object, and then I will try to access and execute the display function inside the car class. So let's rerun the program. But here the problem is that once again the display function of the vehicle class has executed. That is because pointer is of base type. So to solve this problem, we are going to declare the function inside the base class as virtual using the keyword virtual over here, and if we now execute the program, the output will be different. So here you can see this time the output is this is a car. That means the function inside the derived class has executed. So this is how virtual functions work. If we delete the body of a virtual function, then it becomes a pure virtual function. The syntax of a pure virtual function is like this. First we mention the keyword virtual, followed by the return type of the function, followed by the function name, and then we assign it value 0. Pure virtual functions are meant to be redefined in the derived classes. If a class contains one or more pure virtual functions, then it becomes an abstract class. Such a class is not meant for creating objects. Rather, it acts as a blueprint for the derived classes. In simple words, we can say that an abstract class is used to define an interface or a common set of behaviors or methods that the derived classes must implement. Now suppose that if I delete the body of this virtual function and assign it value 0, then this function becomes a pure virtual function. And the vehicle class in this case will become an abstract class because it is used only for derivation purpose and it only provides the methods that should be implemented by the derived class. So this is the entire concept of pure virtual functions and abstract classes. Once again, the output will be this is a car, as only the function inside the derived class is executed.